المبنى مستخدمين مخارج الطوارئ الواقعة على الجانب الأيسر من القاعة. يرجى البقاء في نقاط التجمع حتى يسمح لكم بالمغادرة من قبل المسؤولين. حمانا الله وإياكم من كل مكروه. Good morning. We welcome you to the Green Hydrogen Symposium. I'm Layth Al-Fayrouz, Health and Safety Technician. I would like to draw your attention to the safety procedures. If you hear the fire alarm, you should head to the nearest assembly point immediately, without collecting your luggage. The assembly point is located behind the building. You should use the emergency exit, which is at your left-hand side. Please remain at the assembly point until you are given clearance to leave by the officials. May Allah protect us from all hazards. Have a good day. Thank you.
الذي لا إله إلا هو عالم الغيب والشهادة هو الرحمن الرحيم. هو الله الذي لا إله إلا هو الملك القدوس السلام المؤمن المهيمن العزيز الجبار المتكبر. سبحان الله عما يشركون. سبحان الله عما يشركون. هو الله الخالق البارئ المصور له الأسماء الحسنى يسبح له ما في السماوات والأرض وهو العزيز الحكيم.
بسم الله الرحمن الرحيم. الحمد لله الذي أنار الكون بنوره، وسبح الرعد بحمده والملائكة من خيفته، جعل طريق العلم طريق هدايته، الذي أظهر أسرار خلقه بالعلم، وسخر للبشر العقل والقلم، ووهب اللسان الفصاحة في الكلم. والصلاة والسلام على سيد العلماء وهادي الأنام، وعلى صحابته وتابعيه أجمعين. سعادة الدكتور سعيد بن حمد الربيعي المحترم، رئيس جامعة التقنية والعلوم التطبيقية، راعي الندوة، أصحاب السعادة، الأفاضل رؤساء المؤسسات الحكومية والخاصة، منتسبي فروع الجامعة، ولكل المهتمين ببيئتنا حضورنا الكريم. صباحكم طاقة وثورة جديدة تطل برأسها على العالم، جعلة دول الشرق الأوسط مصدرها الأول. الطاقة المتولدة عن الهيدروجين الأخضر أحد عناوين مرحلة ما بعد النفط في خليجنا العربي، وهو من أوائل القطاعات التي اهتم بها حضرة صاحب الجلالة السلطان هيثم بن طارق حفظه الله ورعاه، وقد أعرب عن اهتمامه في مواكبة التوجه العالمي نحو خفض الانبعاثات الكربونية. ونظراً لاستخدام الهيدروجين الأخضر الواسعة في إنتاج الطاقة، فقد وجه جلالته أبقاه الله بمواكبة التحولات العالمية في هذا المجال، والعمل على تسريع إجراءات تنظيم هذا القطاع القانونية والسياسات اللازمة لنموه. أيها الحضور الكريم، تأتي هذه الندوة لتسليط الضوء على آخر المستجدات فيما يخص صناعة الهيدروجين الأخضر، وربطها مع مؤسسات التعليم العالي في السلطنة، وبحث أوجه التعاون التي يمكن إيجادها بين القطاع التعليمي والقطاع الصناعي الخاص. هنا الهيدروجين الأخضر. نترككم الآن مع العرض المرئي.
بما أن الأرض حياة، وجب علينا العمل يداً بيد للمحافظة عليها، إنسان، حيوان أم نبات. جميعنا مترابطون، نؤثر ونتأثر ببعضنا البعض. اختلال بسيط يدمرنا ويدمر كوكبنا الجميل. حق على أمنا الأرض أن نحافظ عليها، ليس فقط من أجلنا بل من أجل الأجيال القادمة.
تأتي مؤسسات التعليم العالي في مقدمة صناع المبادرات التقنية الشابة التي يتطلع المستقبل على البناء عليها، وتعتبر جامعة التقنية والعلوم التطبيقية بشيناس من أهم مؤسسات التعليم العالي التي ترفض اقتصاد السلطنة بالطاقات الشبابية. نترككم الآن مع كلمة الدكتور أحمد الشحري، عميد جامعة التقنية والعلوم التطبيقية بشيناس، رئيس اللجنة المنظمة للندوة، فليتفضل مشكورا.
بسم الله الرحمن الرحيم. الحمد لله الذي بنعمته تتم الصالحات، وبمنه وكرمه تعم البركات، والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. سعادة الدكتور سعيد بن حمد الربيع المحترم، رئيس جامعة التقنية والعلوم التطبيقية راعي الندوة، أصحاب السعادة الولاة، أصحاب السعادة أعضاء مجلس الشورى، الرؤساء التنفيذيون، المدراء العموم، ممثلي القطاعات المختلفة، منتسبي جامعة التقنية والعلوم التطبيقية وفروعها، أيها الحضور الأكارم. تعتبر الطاقة أهم السبل لتحقيق الرفاهية الاجتماعية وتطلعات الشعوب نحو تحقيق مستقبل أفضل، وذلك لاعتبارها المحرك الحيوي والرئيسي للتنمية الاقتصادية، كما أنها الأساس في تحقيق الطموحات المرتقبة للشعوب، والتي ترتبط ارتباطا وثيقا بتوافر الإمدادات الآمنة لمصادر الطاقة. وكما لا يخفى علينا جميعا بأن سلطنة عمان قد دخلت بمساع جادة مع بقية مثيلاتها من الدول المجاورة في مضمار سباق إنتاج الوقود الأخضر لرسم مستقبل أخضر وبتقنيات خضراء، وذلك لتحقيق آفاقها المستقبلية وتطلعاتها في سوق الطاقة وتحقيقا لرؤية عمان 2040. وفي هذا السياق قدمت 9 دول عربية بما فيها سلطنة عمان مساهمات كبيرة في إنتاج الهيدروجين الأخضر كجزء لا يتجزأ من التزامها بحماية البيئة والحد من الانبعاثات الكربونية والغازات الضارة التي تسببت في ظاهرة الاحتباس الحراري ووحشية المناخ. وقد وقعت هذه البلدان التسعة مذكرات تفاهم بشأن إنتاج الهيدروجين الأخضر واستخداماته، إلى جانب جلب 34 مشروعا للهيدروجين الأخضر للمنطقة. وعلى المستوى العالمي هناك أكثر من 500 مشروع للهيدروجين الأخضر باستثمارات إجمالية تزيد عن 530 مليار دولار أمريكي، وتهتم 40 دولة بتطوير سياسات وطنية وخطط تطويرية لإنتاجه. ووفقا لوكالة الطاقة المتجددة آيرينا 2021 تجاوز المعدل السنوي لإنتاج الهيدروجين من الغاز الطبيعي والفحم الأحفوري 120 مليون طن. وفي الوقت الحاضر تمثل التكنولوجيا الصديقة للبيئة أكثر من 95% من إنتاج الهيدروجين العالمي، ومع ذلك من المتوقع أن يصل إنتاج الهيدروجين النظيف إلى 700 مليون طن بحلول 2050. أيها الحضور الكريم، تعتبر سلطنة عمان مرشحة كأحد الدول المثالية في الشرق الأوسط لتكون بمثابة مركز لإنتاج وتصدير الهيدروجين الأخضر، وقد قامت الحكومة بالتعاون مع الشركات المختصة لبناء اقتصاد هيدروجيني أخضر قوي. وفي هذا الصدد اتخذت سلطنة عمان عدة خطوات، من أهمها تشكيل لجنة وزارية تضم فرقا فنية متخصصة في تنسيق وتطوير جهود قطاعي الطاقة المتجددة والهيدروجين، وتدشين مشروع هايبورت الدقم ومنصة شركة هيدروجين عمان هيدروم. كما دشنت سلطنة عمان استراتيجيتها للحياد السفلي والسياسة الوطنية البيئية للطاقة. وكون جامعة التقنية والعلوم التطبيقية شريك في تحقيق هذه الرؤى والاستراتيجيات سابقة الذكر، فقد اتجهت الجامعة بتوجيه من سعادة الدكتور رئيس الجامعة المحترم إلى تشجيع ودعم البحوث العلمية ذات الصلة وعمل الورش والمنتديات والندوات بذات الموضوع. وقد آتت هذه التوصيات والجهود ثمارها، وإحداها هذه الندوة التي تتشرف فرع الجامعة بشناص بتنظيمها، حيث تأتي هذه الندوة إيمانا منا بأهمية الشراكة بين القطاعين الأكاديمي والصناعي للمضي قدما مع الجهود المبذولة للنهوض بقطاع الهيدروجين الأخضر والطاقة البديلة في سلطنة عمان. وفي الختام أود أن أعرب عن خالص الشكر والتقدير والامتنان لسعادة الدكتور رئيس الجامعة لتفضله برعاية هذه الندوة، والشكر موصول لكل الحضور وللإخوة والأخوات أعضاء اللجان المنظمة لهذه الندوة، متمنيا لكم ندوة متميزة ويوم سعيد بإذن الله تعالى. والسلام عليكم ورحمة الله تعالى وبركاته.
أيها الحضور الكريم، بدأت ثورة الطاقة الناتجة عن الهيدروجين الأخضر تلقي كلمتها وتصبح من أولى مراكز الطاقة المطلوبة في العالم. ندعو الآن الفاضل توماس كوستا مدير الطاقة والصناعة بميناء صحار والمنطقة الحرة لإلقاء ورقة عمل بعنوان دور الهيدروجين في صحار وسلطنة عمان. We invite Mr. Thomas Costa to deliver his speech.
Good morning. My name is Tom Costa, Program Manager, Energy and Industry in Sohar Port. I've been working in the port for 5 years, and since September, I've been supporting the So Sohar Port and Free Zone is a joint venture between the Omani government through the Asiad Group and the Port of Rotterdam. Port of Rotterdam is the largest industrial port of Europe. It's a port of which is 40 kilometers long. It goes from the sea all the way into the interior of the Netherlands. Um, um, Sohar Port is an integrated port where 70% of the goods that enter Oman or leave Oman, they go through Sohar Port. So most of the goods that people buy in a supermarket, the cars that you buy, the food that you eat, enters Oman through Sohar Port and Free Zone. We are connected with 85 ports around the globe. So we're connected with Asia, we're connected with Europe, we're connected with United States, we're connected with China, Japan, Singapore, and many other ports. Our port is a port and a free zone, two industrial hubs connected by what we call Sohar Gateway. We have a port with marine access, we have an industrial hub with heavy petrochemical industries and metals. And then we are connected then to the free zone, which is also within the management of Sohar Port and Free Zone. Adjacent to it, we have Sohar Industrial State and Sohar Airport. You add excellent connectivity with a new expressway, and this all creates this logistic ecosystem, which we refer to as Sohar Gateway. Sohar, it has attracted up till around 30 billion of investment in its short history of 20 years. This is a massive number. It's now home to 20,000 people who have direct jobs in Sohar Port and Free Zone. These are direct jobs. If we add the indirect jobs, it's hard to determine how much those are, but we use sometimes a factor 2, factor 3, sometimes even a factor 4, depending on how far you go with the whole job supply chain. We have 70 million tons of goods entering and leaving Sohar Port. This is a massive number. So it makes Sohar Port one of the biggest players in the region when it comes to the transport of goods. But today, we're here to talk about hydrogen. So hydrogen, you can produce hydrogen in several ways. The cheapest way, the most common way recently, is to produce hydrogen from natural gas. This is what we refer to as gray hydrogen. You start with natural gas, you react it with steam, and you split the CO2 and the hydrogen. The CO2, you release it up the atmosphere. The hydrogen, you keep that, and you provide that to the industries. So in Sohar or in Oman, we use gray hydrogen, so this, let's call it polluting hydrogen, for the steel production. So we have a steel cluster in Sohar. We use this hydrogen also to produce methanol. We have a methanol company in Sohar, but there's also a methanol company in Salalah. We use hydrogen to produce ammonia and urea. We have an ammonia and urea plant in Sohar. We have an ammonia and urea plant in Sur, and we also have an ammonia and urea plant in Salalah. Hydrogen is also essential for the refining operations. And as you can see, hydrogen has been a business enabler for the growth of Oman. Industries from around the world, they're looking for cheap hydrogen. And they came to Oman because Oman had natural gas. So this cheap hydrogen from natural gas was used as a way of attracting foreign direct investment, a way of creating jobs, a way of modernizing, industrializing Oman away from the oil and gas industry. Now, there's a new way of producing this hydrogen. It's from a green source. It does not result in the emissions of CO2, which has very negative impact on the climate. So the industries in Sohar and in Oman and around the world are now looking for ways of decarbonizing their processes and to tap into renewable energy to produce green hydrogen, to supply hydrogen for their industries. We have economies in Japan, Korea, Germany, United States, England, all looking for the cheapest source of green hydrogen to make sure that these industries in their home countries can operate in a green way. In Oman as well, industries here are looking for cheap sources of clean energy so that they can operate, so that they can expand their projects. We have international investors that want to come to Oman to build new steel plants, new ammonia plants, new methanol plants. Oman is being seen as one of the best locations in the world to produce cheap renewable energy. And when cheap renewable energy, you can produce cheap hydrogen. With cheap hydrogen, Oman can use that to attract new investments to this country. So when it comes to the decarbonization efforts in Sohar Port and Free Zone, we focus in 6 different areas to reduce the dependency of Sohar on fossil fuels. Energy efficiency. This is one of the easiest ways to save energy. We can do it in our industries, we can do it in our businesses, we can do it in our commercial buildings, we can do it at home. This is a way of you can save energy, sometimes just by behavioral change. We focus on renewables. So we have in Sohar a solar plant that already provides renewable electricity to one of our steel plants. This reduces the dependency already on fossil fuels. One of our industries can now produce a part of their product green. And this is used then to export a product which has a lower carbon footprint to new markets. We're focusing on hydrogen, green hydrogen, which I will touch on later in my presentation. Synthetic fuels is also very important. We are a marine port, shipping lines. They will be looking for ports where they can offer fuels with low carbon. So we're looking at LNG, we're looking at biofuels, we're looking at synthetic fuels as a way of providing new services for shipping lines. When a shipping line comes from Singapore to England, they want to refuel on the way. If they can refuel in a location where there's cheap, affordable, clean energy, they will go to that port. And when they go to that port, they will not only do fueling, they will do commercial activities, they will do crew change, they will do maintenance, they will resupply, and so on and so forth. So there's, next to clean fuels, there's a large number of additional services that can be provided, which again creates jobs and attracts additional investment. Carbon capture and storage. This is also a topic that we are looking extensively into in collaboration with PDO, collaboration with Shell, because we can capture CO2 in the port, but we need to put it underground in a depleted oil field. So here, this is where ports, oil and gas companies, and academia come together to try and decarbonize Sohar port. The toughest one is actually heat. We are in Oman, it's extremely hot here, but still industries, they need heat that goes to 200, 300. Certain processes, they need to go above 1,000 degrees Celsius. How do we decarbonize this? How do we provide the heat that industries need in order to operate? These are tough challenges that we need to solve, but we cannot solve it ourselves. We need academia to support us in these efforts. As a proof of our commitment, Sohar Port and Free Zone, together with Shell Development Oman and one of our industries, we've established the first captive power utility scale PV plant in Sohar Free Zone. This is a 25 megawatt solar plant, 50 hectares, where you have 88,000 solar panels installed, providing clean electricity to one of our industries. I believe this is as much power as 25,000 households. In addition, we are working with Jindal Shadid to provide green hydrogen for their plant. To produce steel, you need hydrogen. Currently, they're using natural gas for their process. We're trying to supply them with green hydrogen. It's a complex process as well. We have support from German government in form of grants. We have participation from industrial leaders such as Siemens, Linde. Academia is being involved. We have the support of German University of Technology. We have the support of Aachen University. And here, this is a proof where technology, academia, industry come together. To support this effort, the ministries are also being very supportive of this, because we need new regulatory changes to make this happen. And it was with this project in mind that 6 ministers, together with the Sultan himself, went in June to Germany to understand what is green hydrogen and what is the potential of green hydrogen for the Omani economy. So Sohar, we pledged to commit to Oman's net zero targets by 2050. So Sohar Port, we are the largest industrial hub of Oman. It also makes us the largest emitter of CO2 of Oman. So if Oman wants to be CO2 neutral, we need to be CO2 neutral. We want to develop the green hydrogen value chain. Hydrogen needs to come to Sohar. We don't have wind in Sohar, and we don't have much land for the development of renewables. So we need to develop that value chain. Hydrogen needs to come to Sohar, and the products, green products made in Oman, it needs to reach its market. So we are in the middle. So that value chain needs to be developed. We want to retain current businesses and attract new businesses. I often say I can find five very good reasons to do a green hydrogen project in Duqm, but I have 20,000 good reasons to do a project in Sohar. That's a number of direct jobs that are currently dependent on hydrogen. And this is a very powerful message that we need to say. 5 good reasons in Duqm, 20,000 good reasons in Sohar. We want to increase the ICV and the contribution to GDP. Step away from the dependency of fossil fuels. Step into renewables. If you're going to renewables, that's new technology, that's a whole different types of jobs, that's high-tech jobs, complex jobs. It needs engineers, it needs lawyers, it needs different kinds of professionals in order to make that economy work. And this is where Oman, together, industries, academia, they need to provide those skills for the upcoming sectors. And we want to collaborate with national and international partners. So green hydrogen is connecting nations. It's not connecting only economies, it's connecting nations. Policies need to be drafted in Japan and Korea in combination with the policies that are being drafted in Oman in order to make this value chain work. So governments from both sides need to work together. And we're seeing this. We're seeing bilateral agreements, MOUs being signed between different ministries of Oman, between governments, in order to unlock this opportunity. Ultimately, we want to develop green bunkering and the export potential so that ships from around the world, when they sail from Asia to Europe, they make Sohar their port call. They need to come here. So the objective, so now I'm stepping into my other role. I have, as I mentioned, I've joined Hydrom as well. So it's a secondment, part-time, 2 jobs, 1 paycheck. Oman as a whole. The goal is to ensure the energy security for Oman. Oman is very dependent on oil and gas. Those reserves may start depleting in the near future. Oman knows they have 10 very good years ahead of fossil fuels. But beyond that, the future is uncertain. So stepping into the renewables in order to ensure the energy security for Oman is critical. We need to diversify the local economy. So we want to onshore the supply chain. So if we're going to build wind farms here, wind turbines, can we build the blades here? If we're going to install solar panels in Oman, can we attract businesses that will build the solar panels here or provide those services? We have aluminium industries. Can we build the trackers here, those equipments that are installed under the solar panels so that the solar panels can follow the sun? These are all elements that we are assessing. So with the energy transition comes new industries, and that's new jobs. We want to decarbonize the country. So reduce the CO2 emissions of Oman. We want to create a green hydrogen sector. So we have a very strong oil and gas sector. Oman has a lot of experience in dealing with complex industrial projects. Oman can leverage on that experience and then step and use that experience to develop complex green hydrogen projects. We want to support innovation and ensure that capabilities are developed in Oman so that the young students of today will be the ones that will be solving the challenges of tomorrow. If we put all of this together and looking at the green hydrogen space in Oman, we expect, or the government of Oman expects, that by 2050 we'll have roughly 140 billion US dollars of investment on the ground in Oman. This is massive. So the more skills are developed in Oman, the more value of this is retained in the country. Oman's targets are clear. We want by 2030 to be able to produce 1 million tons of green hydrogen. This means that we need to have 20 gigawatts of renewable projects on the ground and 10 gigawatts of electrolyzers. This might mean an abstract number, but for the sake of comparison, 20 gigawatts is currently what is installed in the North Sea, installed by Denmark, Germany, the Netherlands, England, and Scotland together. This is 30 billion US dollars of investment. The projects of Hydrom, the land allocation process for 2023 is going to ensure that developers are allocated sufficient land to meet these targets. And we will not stop there. 2040 will increase from 1 million to 3.5 million, and then to 2050 to 8 million. But the first one, this is a hard target. This is the mission of Hydrom, to ensure that there's an industrial sector in Oman to produce 1 million tons by 2030. To do so, okay, this slide is not very clear. Sorry. This is Oman, Muscat, Sohar, Duqm, Salalah. In order to execute these projects, Hydrom has been allocated 50,000 square kilometers of land. This is land in Sohar, in Salalah, in Al Jazeera, and in Duqm, with additional lands being reserved for potential future expansions, also for OPWP, for the domestic power sector. Hydrom's focus at the moment is on this section, where we will be awarding the first blocks by March 2023. So this is in 3.5 months. From today, we will be awarding 5 blocks in Duqm. In addition, we will be working also in Salalah for the additional blocks for December 2023. And we will not stop there. So beyond that, we will be looking at additional blocks and trying to see how can we provide renewable energy, clean hydrogen for present and future industries. My role in Hydrom is also to make sure that there's interest captured for Sohar. So Sohar is being seen as the greater challenge, because to produce cheap green hydrogen, you need wind and solar and a lot of space. So you have that in Duqm, you have that in Salalah, but unfortunately in Sohar, there's not much wind. So in order to produce cheap hydrogen, you need both. And in order to provide hydrogen to Sohar, we would need a pipeline of hydrogen or high voltage power lines. However, this distance is quite extensive and the projects would be very expensive. So step one, we want to activate the market. We want to see the potential of these green hydrogen projects for Oman. This is a small risk. So if Oman invests a little bit of money on a pipeline which is 50 kilometers and it doesn't go well, Oman can absorb that risk. But if that pipeline is 1,000 kilometers and the project does not go well, that's a whole different matter for the national finances. To clarify how the sector is now organized, the policy and the regulations, this falls under Ministry of Energy and Mines. Sun and wind is a national resource. You can produce energy from it, and as such, it is the responsibility of the Ministry of Energy and Minerals to regulate that space. So this is His Excellency, the Minister Al-Aufi, together with the new Director General, Abdulaziz Al-Shibani, who are regulating this space. They set a national strategy for Oman. Hydrom, or Hydrogen Oman, is an entity that will orchestrate a master plan and coordinate the green hydrogen space. So, using the land that has been allocated to Hydrom, Hydrom will create blocks of land and will bring that to the market on a tendering process, very similar to the oil and gas. We know that there is potential to develop renewables, and we're challenging international developers, international companies to say, here's a block of land, propose us your project, show us what you're going to do with it. Hydrom will negotiate on behalf of Oman to ensure that there's value captured for the Omani economy. So it's not only what is the value for the developer, no, what is the ICV element for Oman? How much of your industries are you going to be onshoring? Are you going to invest in academia, training? Where are you going to source your materials, in the manufacturing, the services? How much are you going to spend on local SMEs? This is all the responsibilities of Hydrom to ensure that we give the projects to the companies that have the best merits, that can add the most value for the Omani economy. When it comes to common infrastructure, it's also the role of Hydrom to coordinate that space, to master plan that space. So we will need hydrogen pipelines, we will need desalination plants, we need high voltage power lines, the ports need to be prepared to receive these projects. We created master plan, we communicate with the several stakeholders which are already on the market, and we provide them the information they need so that they can plan and orchestrate and develop their infrastructure. Not only for the first projects that are coming, but to make sure that they know what is coming in 2024, 2025, 2026, and so on. And all this so that the developers, they only need to focus on the financing, on the renewables, on the production of green hydrogen, derivatives, in order to sell the product to the market. The shipping part, Asyad, the logistics arm of the Omani government, they're positioning themselves as well to ensure that if there's a product with the label made in Oman, it's going to leave Oman on an Omani ship with the Omani flag. When it comes to a process, just to give an indication of how we are doing, we're providing a transparent process for developers. We are cutting all of the political red tape. We have the support of the several ministers in order to execute this strategy. So the tendering process for the lands started in November this year. We are selecting only the best companies to participate in these blocks. These are companies that have the capabilities, the experience, the financial backing to execute projects, since each one of them is estimated to cost anywhere between $5 to $8 billion US. So we only want the heavyweight companies to come to Oman and execute their projects. Once a consortium or a company qualifies, they will be invited to propose their project. They will have 2 months to develop a project proposal. In February, March, we will evaluate them, and by the end of March, we will award the first projects for Oman. So Sohar was greatly impacted when the Liu Plastics project was being built. These were 10,000 workers coming to Sohar to build this mega project. Potentially here, we will be awarding 5 of them in one time. And in December, another 5 in Salalah. So it's not only about the green hydrogen, it's also about the jobs that are needed, the accommodations, how do you feed these people, how do you do the logistics, how do you provide the equipment, how do you provide the material, is there sufficient concrete, is there sufficient steel, copper, technology, services, education facilities. How do you provide the skills so that when the contractors come here to start building, they can rely on local manpower to meet, to supply their projects with the skills that the projects need. Ultimately, this is how the project will look like. We start with desalination plants. We desalinate water. We bring the water to the interior, to these blocks. And then using solar and wind, we split the water into green hydrogen. Green hydrogen is going to be transported to the ports and to the special economic zones. Here it's going to be converted to to ammonia, to methanol, to steel. And once the products are done, they will be stored and exported again. And part of it will also be used for the domestic market. Gentlemen, thank you very much.
نشكر الفاضل توماس كوستا وندعو الدكتورة سوسن الريامية مدير مركز الهيدروجين الأخضر في سلطنة عمان لتقديم ورقة عمل بعنوان اقتصاد الهيدروجين في سلطنة عمان.
Good morning, everybody. I thought it's by English language, and thank you very much for the organizer, Your Excellency, colleagues, professors, and young leader for hydrogen. Our students, welcome today for today's sessions. I'm not going to repeat what Tom Costa already said. It's already the green hydrogen economy. The presentation will be refocused, the focus on the play or the role of Oman Hydrogen Center. So it's not Hydrogen Oman anymore, it's Oman Hydrogen Center. So it's more directed to R&D, economical and technical visibility study, and side by side with our industry. So who are we and what is Oman Hydrogen Center? Before we go, I would love to give you an overview on this ladder shape to tell you the massive initiatives and effort done by you, Omanis, and other partners to bring hydrogen to reality. It's not an easy journey. First, in 2018, sort of people in a university started to think about hydrogen to be one of the solutions to our diversification of our economy. This is one. The second group and ministry are thinking if it is deserve or will deserve to be in nation level, and we have to work jointly with decision maker industry to go through the visibility study and decide if hydrogen will take place or not. All of this is 2018, which is not yet shown. And then other group with the Oman Investment Authority and Belgium, they decided how about doing a pre-visibility study and go together with Dimi company in Harper.com, which it is one of our famous projects here in Oman. So the journey was long, and the journey has been started a long time ago. And I want you to bear attention here that is what is the massive effort that is 2022 has been taking place, and people start to follow His Majesty decree when they decided to establish hydrogen development Oman that was rebranded to be Hydrogen Oman, because they are not going to develop any project, they are going to take place to orchestrating all of this mission. To have hydrogen project is not an easy journey, and we understand the pressure on the shoulder of our decision maker. Their decision is our economy future. So I personally respect it, and if we are delaying a bit here by slow things, we finally, hopefully, with several efforts, like I can highlight hydrogen development Oman to be rebranded, and setting net zero emission for 2050, and now we have been thinking seriously What is the role of hydrogen towards this net zero emission 2050? Also, we cannot skip what's happening in Oman, the announcement of 2050 vision for net zero emission. This is another load in our shoulder. It's about our behavior, about social behavior. How do we achieve that? And all our projects now titled either to be renewable energy, decarbonization, or hydrogen. At least in our university we decided, and other colleagues, let's search more and more on those topics. In Oman journey, our energy transition are crystal clear. If we talk about oil, and then we are talking about liquid natural gas, renewable energy, and then the hydrogen coming in this place. We, under Hydrogen High or Hydrogen Alliance, these are the organizations that are being involved here, where German University of Technology, that the Oman Hydrogen Center is under their umbrella, is one of their key players, and we represent the R&D and innovation side by side with City University. So 15 founders, only 2 from academia, and the remaining are industrial sector, and they align all efforts effectively to integrate the national project. And one of the most important activities that we suggested, perhaps we might need a national roadmap when it comes to hydrogen, when it comes to R&D and innovation, and where our focus needs to be refocused. So we hope this will be decided, and the next meeting already took place on September during the Oman Summit. In our opinion, the main objective for hydrogen economy is energy security, because it could be stored, but you cannot store easily the electricity. Diversification of local economy, support the R&D and innovation, it's in-out, and capability development when it comes to the tools or human beings themselves, and finally, hopefully, green hydrogen might lead for or contribute to the decarbonization. Going back to the slide that has been shown and well explained by my colleague Thomas Costa from Sohar, as you can see, this is the question mark that many investors came to Oman and said, guys, you are too many. Oman Hydrogen Center, Hydro, the ministry, OQ one side, but it's not clear who is on the position to orchestrate in all of these efforts, who will make decisions, how do we do it. So thanks for Hydro Oman, led by Dr. Firas Abdawani, that of course with the great help of Dr. Costa, that they are making it crystal clear here that the developer partner with local partners is OQ, for shipping and diversification is ASEAN, and for policymaker is the Minister of Energy and Minerals. So any investor coming, they just knock the door for Hydrogen Oman, and Hydrogen Oman will guide them in their work. Where is our role in all of this? We are involving in policy and regulation activities. We are involving in infrastructure mapping, and recently we are involving in a close eye with shipping activity with ASEAN. I'll skip that slide because it's been explained by Tom Costa. Well, the journey of this center, Oman Hydrogen Center, quite early, when a pandemic situation has been resolved to slow down all the activity and all the active activity. I will say that the center started in 2022 when hiring a new director. The vision and the mission has been carefully reviewed. More than 10 partners have been signed with the center, and most of them are pure industrial with 2 institutes internationally, RECRI and Erizon. RECRI is located in Cairo, and the other are located in Morocco. And we are cooperating with more than 45 experts over the world, and mainly from Germany. Our vision is to be the innovative hydrogen hub in MENA by 2050, which is not an easy ambition or mission. And our enablers is through a strong advisory board that will be decided soon. And the permanent staff and temporary staff are somebody who are allocating or visiting us on regular basis. Usually the temporary staff coming based on the project, and already we reallocate more than 25% with less than 2 months. That means they are coming based on a project, based in demand, building a specific capacity or capability toward a certain direction. So as a visitor, we did a farewell party for our colleagues from Oxford University. So we are also speaking to UK when it comes to hydrogen. They are really involved when it comes to specifically renewable energy and solar. So what is Oman Hydrogen Center Cooperative and Cooperation? This might be interest for Utah's people here, which we give our word as Oman Hydrogen Center that the center will give all the support for Utah's maybe Shinas or Sohar and finally with Salama by the Q1 this year. And we will be able to link them with all the experts they would like to be with. We are welcoming the joint effort for certain projects directed towards hydrogen. And we sometimes do the funding support and in-kind contribution. And that's what the example between us and Nanotechnology Lab in Sultan Qaboos, or at Sultan Qaboos University. How do we sustain the center, or what is our vision towards the sustainability of the center? Is to do the educational and training program. As you might be very well known, the training program is okay for Oman. You could just announce it or plan it and make it happen. How do you sustain a program for a training? This is a big puzzle. The other things, the educational, when you want to do a master program, you have to really understand the market itself, the skills is needed, because you might end up by very, very qualified people that they miss their career path in the country. So in this regard, we are talking closely with OPAL. We are in a very good contact now to develop, hopefully, if the fund is secure with Germany, an exchange program with one of the leading institutes in R&D, it's the Fraunhofer. And from basic to applied research, we are focusing recently to the applied research. So we are avoiding the basic because we are following the demand of the industry. So we are a driven industry or industrial driven. For the certification, we hold it on a bit because we want to know which things we should certify. Is it the human or the devices themselves? But also to certify the people to be operator or to be a lecturer or to be a trainer. So it's still under exploration. The visibility and economic study for industry, almost 4 studies has been published by the center. Advisory and consultancy, this is based on demand and usually coming from the industry themselves. Those are our main focus area. If you are interested about one of them, we can always discuss. The hydrogen economy, as I said, we are driven by industry, so the ICV, in-country value, is always the element that we are hunting. The techno-economics model, since most of the project in Oman for hydrogen, it's under visibility study, so they approach us in this regard. We've already done an academic summer school with the cooperation with Irizin, our rectory, and it was taking place in Morocco, August this year. We cared also about the technology transfer and knowledge management, and we are very glad that we have been recognized by several stakeholders that approach us that we are in position to play this role in Oman. Those are the list of the projects starting from May till today. The trust from the industry is what is driving us. I want to highlight with big thanks the potential of hydrogen transition for Port and Sultanate of Oman. This is a huge trust from Asia to ask us to draft the report for them that has been launched and Oman Green Summit last week. And thanks for Petrofac for the 2 full-day training for 30 engineering that they have been taking 2 courses. One is theoretical about hydrogen, and the other on-hands training. And thanks also for Soharbort to meld 2 culture together, the Netherlands students and the Omani students. 3 being selected from Oman and 3 being selected from Netherlands. The topic was quite heavy for them, and the deliverables, based on the feedback that we got, it's above a student's level. So we are very proud about the Omani capability that we are already having, and we found it's not difficult that they go and travel to Rotterdam port and understand the situation there. The topic is towards decarbonization of Soharbort, which it is still a heavy duty. This is the certified courses for photovoltaic that is the Global Champs been doing it in German University of Technology. Now the plan is to utilize the setup that is being funded by PB Oman. So great thanks for them, of course. You have this face-to-face on the top of the roof, and then you have this industrial roof, and also what you don't see it because they put it and they leave it, and off the solar panels on the ground. And of course, if you talk about green hydrogen, you have to understand renewable energy. In Oman, there is 2 potential. One is photovoltaic, and the other, which is electricity demand. And the other is the wind, which is another electricity. But also, we are discussing one big challenge that Soharbort already mentioned it in their presentation: the heat. The heat is a massive. Also in Oman, can solar thermal taking place or not? We have one experience. But the technology is 14 technologies. It's not only the mirror technology. And then other people might ask, is geothermal could take place here in Oman? This is another visibility study led by another organization. I just want to advertise this, so it goes very fast, but we did not finish it. So I just want to go for the last slide I present, please. Perhaps number 10? No, number 18. Yeah, I just want to let you know that in German University of Technology, they're also building a technology center that is being built by 3D technology printer, where the material being developed by the students who graduated from geotech, but they are under a huge pressure because they have to deliver it by 3 days before her Excellency Professor Dr. Al-Mahrouki came and opened this. So they didn't know how to print it because they printed the half by 2 months, but eventually they built up this material and they broke the rules of this devices, and we are about to be patented this material. So Oman Hydrogen Center liked the idea, and we wanted to build the 2 floors. Now they built the first floor, so we want the 2 floors, because if they did that, it will be the first largest building in the world, making it green to speak the talk, and it will be unique because the material used already in under process of patent. So this is not the normal cement that you could print it in other location. And this one ticket, I will give it to our graduate. The design also has been done by UPED fresh graduate students. So thank you for our students here for helping the center in our first journey. And this is how the center hopefully will look like. Our aim is to make it a green, smart building. That's why we delay in building it. Finally, these are our stakeholders. And thank you very much for your kind attention, keeping the time safe.
نشكر الدكتورة سوسن الريامية، وندعو الفاضلة نجد الرئيسية محللة في مجال الطاقة البديلة بشركة أوكيو لتقديم ورقة عمل بعنوان اتجاهات الحاضر والمستقبل في صناعة الهيدروجين. نشكر الفاضلة نجد الرئيسية، وندعو البروفيسور راجا موها ناترجان قائم بأعمال عميد كلية الهندسة بجامعة صحار لتقديم ورقة عمل بعنوان الهيدروجين الأخضر، التطورات الحديثة وتحديات التخزين. We invite Mr. Raja Mohan Natarajan to deliver his speech.
Assalamu alaikum. A very good morning to the distinguished dignitaries, His Excellency, the learned delegates from industrial sector, my fellow colleagues from academia, and student friends. I'm the first representative from academia. We have heard enough about the key stakeholders, what they promised for the country and you, and I'll bring you a new flavor that what academia should add. I see a lot of exciting minds here, that how you are going to be part of the bigger agenda, as we say, the green hydrogen concept or Oman 2050 plan. To start with, I was a bit skeptical when I received the invite from the Dean, like we will be expecting for sure my best friend Tom Costa or Dr. Sozan from Oman Hydrogen Center, and I made sure that I should not overlap or encroach what they are going to speak. So I chose to address something critical on the downstream. We talk about green hydrogen, why is it important, how we can produce it, equally significant, how do we store it. And there is a huge scope for engineers representing different disciplines, be it electrical, mechanical, chemical or energy engineering, how effectively we contribute towards safely storing the hydrogen for either short-term use or long-term use. Apologies if I repeat any of the content shared by the previous speakers, either Mr. Tom or Dr. Susan. So green hydrogen is a buzzword, as all of us see it in media, social media, in the agenda of the countries, growing economies, and even academic research. So the current presentation will be more focused on the current technologies prevailing and the storage challenges for the green hydrogen. Again, this is a key item which is commonly found in all our presentations. Oman has set a very ambitious target, like a lot of other countries aiming net zero by 2050, and green hydrogen presents a huge opportunity for achieving that 2050 target of net zero, which is towards decarbonization. And we have set an ambitious goal to become a leading green Oman producer and exporter with an expected target of 1 million tons by 2030, which is very close, 7 to 8 years from now. So we have a short-term goal, and of course we have a long-term goal, which is a bigger agenda. So what's this hydrogen all about? A bit of academics. What do this hydrogen will help? Is it only decarbonization, or is it an alternative energy? Where do we go with this green hydrogen? Is it new, really new, or is that been in existence over this decade? And hydrogen energy system is seen to be a best solution for promoting sustainability. It's a very clean technology which serves both decarbonization and the environmental protocols of the United Nations. Future hydrogen economies will use green hydrogen production methods to generate ammonia. A bit of repetition what Tom and Dr. Susan has said. Ultimately, it leads to a lot of value-added chemicals, namely ammonia, fertilizers, to generate synthetic fuels. And of course, hydrogen itself is a fuel, so our dream in the future could be driving a hydrogen-powered car. Again, a bit of schematic to make it maybe interesting for the student community. We call hydrogen by different names. Unfortunately, hydrogen is a colorless gas, to keep it simple. We call it gray, blue, green. And of course, they don't have any relationship. So the gray hydrogen, which is being with us since ages, hydrogen is not anything new. It is part of the petrochemical business, which we have been handling since a long time. Gray hydrogen is a classical process where we use natural gas to produce hydrogen. This is what the refineries do. Then subsequently, we added what we call as CCU, carbon capture and storage. When you add CCU to the classical gray hydrogen, gray changes to blue. So blue hydrogen is nothing but it is a CCU integrated gray hydrogen. It's very much possible. Where we are right now is green hydrogen, which is purely renewable energy integrated electrolytic splitting of water. It's very simple. It's an academic explanation we give. Anybody can understand how green hydrogen is unique or why is it going to be important. And we say it is renewable energy, it doesn't mean which form of renewable energy. Of course, for Oman, the priority will be either for solar PV or for wind energy, which two are the nature's gift to Oman. Theoretically explaining, this is how we explain how do we call grey hydrogen as explained by the OQ specialist on decarbonization. It is a classical steam reforming. Where do we work on grey hydrogen? And of course, grey hydrogen is, as we call, it's a dirty gas with a lot of carbon dioxide produced. And coming to the blue hydrogen, it's an improved method where we do convince industries through CCU, carbon capture and storage, but still it is not widely accepted that still they claim 10 to 20% will be released. So again, it's not anything solving the 2050 vision. So to overcome all these challenges, we went into what we call as green hydrogen technologies, where we need to clearly integrate renewable energy for electrolytic splitting of water, where we produce hydrogen in the purest form, and your technology will be accepted as green technology only when you emit 0% carbon dioxide. Let it be very clear. It's zero discharge, and currently all over the world 0.1% of the overall production is through green hydrogen. Till we need to go a long way. This is why our vision document says 2050 in the long term. Until 99.9% of the hydrogen are either through grey or blue hydrogen technologies. This is about how do we see hydrogen, green hydrogen leading the way. To give you a quick overview of the current technologies in practice. Apologies if I take the topic of the subsequent speaker, as she is going to speak on hydrogen production technologies. These are the currently available methods. All these are in practice. Starting from steam reforming, which we talk about grey. Most of the first three are all grey, a bit of blue. Then we go for biological methods, which is green. Again, we have thermal methods, which again is a grey technology. Then towards the end, what we talk about is the electrolytic manufacturing, which is electrolysis. As you could see, it is one of the expensive. Very clear. The agenda is very clear. Green hydrogen is going to be expensive unless or otherwise you justify very abundant availability of renewable energy, and again economies of scale comes. Only in a large scale economy, green hydrogen can be justified as a cost effective technology. Conventional methods are all going to be cheaper. As I say, dirty fuels are cheaper, clean fuels are always expensive. Unless or otherwise, we invest a lot on research and development to achieve a very economical scale to compare. So coming to what I wanted to emphasize today, and most of the people who have spoken earlier, they spoke a lot about green hydrogen, why is it important. I'll be touching more towards storage technologies, where all engineering have a very effective role to play. And we have a lot of storage challenges, especially with hydrogen. It's not easy to store hydrogen either for short-term use or long-term use. It has operational challenges, also it has economical challenges. Broadly classifying, the hydrogen storage are usually done either through a physical mechanism or a chemical mechanism. Physical mechanism, as we study with mechanical engineering, energy or chemical engineering, we talk about storing liquid hydrogen, storing compressed hydrogen, then storing cryo-compressed hydrogen, which is with the use of nitrogen gas. Coming to the chemical hydrogen, is quite interesting. For chemical storage, hydrogen can be stored in different forms. Need not be as hydrogen. It can be stored as a hydride. You will store it in a safe form, in economical form. During usage, you can get back the hydrogen in what form you want. This is quite interesting where I say chemical hydrides, metal hydrides and sorbents play a very key role in how efficiently we can store hydrogen. And this is where most of the leading universities and organizations are working towards identifying and developing novel methods with very high efficiency and low cost. It's of huge interest if anyone from academia would like to complement the industries for storage. Of course, like any other gas, you can store hydrogen underground. It's like a natural underground storage. For, for having a very safe and sustainable hydrogen storage, a lot of inputs from geology, either both from the geophysical part and the geochemical part. We need to have a complete idea about what site we choose, and we need to have a very good understanding of the structural depth, tightness, tectonic and seismic issues, hydrogeological and geothermal issues, reservoir pressure. A lot of geological input is required whenever you want to store a gas underground in a very safe way. So the metallic containers are the classical examples. Where do we have? The metallic containers have been used since long time. How do we store a nitrogen gas? Is similarly for hydrogen too. Metallic containers gives you a very prospective opportunity. They are very integral and they can withstand any climatic conditions. Of course, for the safe storage, we store the containers below the ground, below few meters. Generally, using underground containers provides you advantages like space saving, additional protection against physical impact and weather, reducing insulation cost. What are the challenges when we have underground storage is monitoring. Monitoring or fault detection is not easy whenever we have underground storage systems. And of course, corrosion underground is a very significant challenge when we talk about underground metallic containers. A very interesting prospect when we talk about green hydrogen is rather than storing it as a gas, it can be compressed and stored as a liquid, like LPG. Liquid storage gives you a lot of advantage because the density of hydrogen reaches around 70 kilogram per meter cube at atmospheric pressure, and liquid hydrogen holds a calorific value 2.8 times that of gasoline. Of course, that you can imagine it as a super fuel with a very high calorific value. However, energy intensive liquefaction mechanism, we need to find a way how to liquefact it in an energy intensive way to justify liquefied hydrogen storage is going to be the future. And hydrogen is always a bit of a sensitive component to handle. As you say, the boiling point of hydrogen is minus 253 degrees Celsius at 1 bar, and hydrogen gas does not cool down during throttling. A bit of interesting refrigeration and compression concepts for mechanical, energy and chemical engineering disciplines. There are a lot of challenges associated with storage of hydrogen. Why do liquid hydrogen is interesting? Of course, it is a zero emitting production and it has the best energy to weight ratio among the fuels. Liquid hydrogen have a higher calorific value, 2.8 times. Its density is comparatively higher than hydrogen gas. Liquefied hydrogen is always giving you a lot of prospective advantages. The disadvantages with hydrogen are, of course, it is a dangerous fuel to handle with. Very high flammability, expensive. The liquefaction process requires very high energy. It requires special storage tank design, which are the challenges which we will face when you want to commercialize the use of hydrogen for automobiles and other purposes. Going into some technical aspects of what are the currently practiced technologies for storing hydrogen. Either you choose a physical technology or a chemical technique. So adsorption is one of the key methods where a lot of material with very high surface area, namely activated carbon, metal organic frameworks have been successfully tried to store hydrogen. And what is very interesting, you need a pressure of between 10 to 100 bar, and we operate at a temperature of minus 196 degrees Celsius. Very high cost of refrigeration, of course, very high pressure are always going to challenge the feasibility of the process in terms of energy requirement. To make it a bit interesting, this is how we explain how do we store hydrogen. Either you store it in the form of an adsorbed hydrogen during storage. When you want to use, you can desorb hydrogen from the medium where you are storing. It's of course a high pressure, low temperature technology. So we need to strike a balance between what material you synthesize new. A lot of research is being currently handled to developing new material where you can store hydrogen at a comparatively lower pressure and a higher temperature. Lower pressure is very high cost. Again, low temperature is high pressure is very high cost. Low temperature is very high cost. We need to strike a balance between them, which is going to be the challenge. And this is a new perspective. How do they store? They don't store hydrogen as hydrogen. It is stored in the form of hydride. We call it metallic hydrides. Metallic hydride is a form of storing hydrogen. So if you want to use hydrogen, we dehydrogenate hydride. So hydrogen will be released from the compound. This is a very emerging technology which is going to serve a long-term hydrogen storage in a very economical way. These are the technologies which is being currently developed, and all these technologies have been in development over the past few years. So this gives you a summary of what are being tried elsewhere, a bit of an academic survey. So compression at a temperature of 290 degree Kelvin and 4 megapascal is a possible process. The electrochemical efficiency is 98%. Cryogenic compression has been tried. Cryogenic, of course, uses nitrogen gas. So you can see pressure in the range of 10 to 45 megapascal. Whenever the pressure is high, you could achieve better efficiency at low temperature. Whenever the pressure is low, of course, you need to go for a still lower temperature. This gives you the current status of the various physical methods that are being used for storing hydrogen successfully. Coming to the chemical part. So significant research has been carried out in what new material you can produce, namely activated carbon from a lot of natural resources, and successful results have been produced where hydrogen storage capacity up to 6.5% have been achieved by using naturally available biomaterial to convert them to activated carbon, and activated carbon is successfully used to store hydrogen. These are the technologies currently under research and development which could prove very effective when you want to use it for a large scale industrial storage. To give you a critical comparison of is hydrogen to be stored as hydrogen or the rest of the world think different. Now new thoughts have been emerging like hydrogen need not be stored as hydrogen. They propose storing hydrogen as ammonia. The future direction is not a hydrogen fuel cell. They are talking about an ammonia fuel cell. You can store ammonia in a safer way, and they want to take hydrogen from ammonia, which is a reverse. What do we do now for green ammonia is we use hydrogen to produce ammonia, but a future direction they are thinking for storage purposes, they could think about green ammonia. From green ammonia, they want to take green hydrogen, which could be utilized in the engineering systems. These are some new thoughts which are under development in different applications. The future perspective, the improved performance of hydrogen storage materials is very conducive for future applications of hydrogen as a fuel. Let us talk about hydrogen have multiple roles, and one of the leading roles for hydrogen is as a fuel. And of course, we dream about having a fuel cell driven automobile starting from a car to an airplane. So improved performance of hydrogen storage is very important. As an important part of new energy technology system, hydrogen energy is expected to be the best way to store centralized renewable energy in the long range and in a large scale. New research have been started focusing on several challenges in terms of producing new material for storage, but there are a lot of challenges when they wanted to apply in reality, and academia have a very strong role in collaborating with the industry in developing new materials for storage of hydrogen and in developing new materials for improving the electrolytic performance of PEM cells. To conclude, the global environmental concerns as well as the scarcity and geographical distribution of fossil fuels have led to growing interest of hydrogen as a fuel, as a clean fuel. Of course, hydrogen technologies can solve us to power a range of applications from small scale electronic systems to big scale transportation systems including vehicles and trains. Developing large scale production and storage technology of hydrogen is the only way to support the transition towards a hydrogen powered world. Producing hydrogen from a renewable feedstock, which is solar PV, wind or bioenergy, is the cleanest production technology which is going to solve the national agenda, which we mean either net zero or 100% decarbonization. Some of the main references which I have used for preparing these presentations are listed here, and these are some of the academic research which we have been doing towards green fuels, and as I say, these are some recent literature in some of the world respected highly indexed research journals, namely in International Journal of Hydrogen Energy, where we have spoken on influence of nanomaterial on biohydrogen. The second one is a journal on fuel, where we talk about life cycle assessment on how hydrogen energy technology is going to serve the future of all emerging countries. I take this opportunity to thank the Utah Shinas for such a nice initiative to invite the academia and industries, and always it is a pleasure to work in collaboration with all the HAIs in Oman, and I thank the organizers for giving me this opportunity. Thank you very much.
البروفيسور راجا موهان، وندعو الدكتورة يثرب عجاج، محاضر أول بقسم الهندسة بالجامعة الألمانية، لتقديم ورقة عمل بعنوان تقنيات إنتاج الهيدروجين الأخضر، استثمار رئيسي في انتقال الطاقة.
السلام عليكم ورحمة الله. His Excellency, the delegates, the professors, researchers, the students, the colleagues, thank you for inviting me today to be one of these good events here in Oman. And so I will not be very boring because I'm from academia. I will try to my best not to repeat what my other colleagues already informed or said or talk about. I will start first with a question. What is the most abundant element on the universe? Anyone knows? The most abundant element on the universe. What? Hydrogen, exactly. Hydrogen is the most abundant element. And of course we have oxygen everywhere. So why we cannot produce water or energy without going through all these challenges? What is the main issue? Students, I'm asking the students because I'm a teacher at university. I love to ask always and solving these challenges. Okay, because we need energy. Yeah, to push out the reaction, the activation energy. So we need to invent energy to produce energy while we are producing water. So how the energy is extracted from the hydrogen? Did you ask yourself how this electricity is generated? Exactly, yes. So you heard from who said about the colors of the hydrogen, Costa and Professor Raja. So yes, as we said that it is colorless. There is many technology in producing hydrogen. The main one was the electrolyzer. My first research was, I will not say the year exactly, so you will not expect my age. I did my master in Stuttgart University, and I did my research at that time, okay, in fuel cell, to find out the lifetime of the proton exchange membrane by changing the series of the polystyrene, have new derivatives, and we try to maximize the efficiency and the lifetime of the membrane. So today there is many technology in producing hydrogen through the electrolyzer, and Ms. Nick already went through some of them, like anion exchange, which is coming now. Yeah, hot topic. Okay, proton exchange membrane, and what else? Solid oxide membrane, but it's still electrolyzer is an issue. Yeah, the lifetime, the corrosion, and so on. So, anyone from the students, anyone knows what is the difference between fuel cell and the batteries? Fuel cell and battery? Okay, fuel cell is a battery that is used to generate energy. And the battery, as Professor Raja, they use it in storage to storage the energy. Okay. So what is my talk now? Okay. Decarbonization, carbon dioxide, emission, green gas or greenhouse gases, hydrogen, all these strategies and all these questions is how to build or how to have a strategy and design that leads us to decrease the carbon dioxide emission, decarbonization. Okay, now as Costa in the first speaker said, the most method used in generating or producing hydrogen is from the methane. Okay, another one, they want now to introduce renewable energy, wind, solar, to produce from the using electrolyzer through desalination water or the water. Okay, here I want to sell the new technology, which is the biomass. I will not talk about other technologies. I know that you already have a hint about it. كلكم تعرفوا التقنيات المستحدثة أو مستخدمة حاليا. I will go. How can I go? Like this. Okay. So biomass, generation of hydrogen through biomass. Hydrogen production, as I said, through the carbohydrates, through the hydrocarbons like methane, 90% until now. And our new technology, which is to produce it through the biomass, and this can happen through different process. Okay, so many microorganisms like eukaryotes or prokaryotes, cyanobacteria, algae, bacteria can produce biofuels or biomass through different methods. Okay, according to the method that they use it to produce energy, biomass, we classify them into fermentive, okay, temperature tolerance, oxygen tolerance, and of course the eukaryotic has a different classification. So as you see, diversity here is not like Ms. Meg said. It's not diversity in the market. Diversity in the culture, in the microorganism. Cyanobacteria, for example, the thermophiles has the biggest chance to produce hydrogen in a big amount. Obligate anaerobes, they have lower potential in producing hydrogen compared to facultative anaerobes. They do that through the metabolism versatility, okay? So hydrogen can be produced from these organisms as a single or as a colostorium, and the colostorium can be from one species like cyanobacteria or algae, or it can a different species mixing cultures. Okay? This can happen in one step, or to improve it as a scientist from R&D in different steps to enhance the production of hydrogen. For example, dark fermentation, photofermentation is like what is happening in our body, how we generate energy in our body. Okay? Eating sugar, for example, breaking bonds, generating carbon dioxide and energy. Yeah, this is the same way as the microorganism is also doing. Okay? Another way is by photolysis. Okay, that is absorbing light and generating and splitting the sugar into hydrogen and energy. So we can, as I said, can combine, we have one method, or we can have a diversity, two methods to generate the hydrogen through that. Okay, how is that is happening? We need three things: sunlight, or a source of light. We need water as a medium. Cheap investors here. And we need carbon dioxide. So the microorganisms, the algae, actually is helping in reducing the carbon dioxide emission because they capture. We can provide them with the carbon dioxide from the air. So the carbon, what they needed in their metabolism, they can get it from the carbon dioxide. So this technology can help in reducing carbon dioxide emission. So, and I will not go in details in chemistry of this process, but for any question later I can answer. So the way that is generating, we have different. So the products can be different, depends on the different substrate and different media. So the pH, the salt, the salt and the temperature, the presence of enzymes can lead to different products. Okay? So our target is to have a biorefinery system. Okay? So in this biorefinery system, actually we want to integrate the wastewater as a medium. So we will use the wastewater, so again, additional things that is be beneficial to sustainability. And then we will use the artificial light if we have it inside, or the sunlight. This also will be cheaper, better outside. And we do our fermentation in our plants, okay, or in the system, and then we can provide the customers with energy. So microalgae now in the world has a big capita. It reaches with 30 billion per year. It's a big market. It's like gold. Yeah, microalgae, they are everywhere in the food supplements. Okay, chlorella now they are using it as a food supplement because it is provides the body with nutrients, with many proteins and so on. Also, microalgae can be entered into pharmaceutical as a supplement because they are rich in omega-3, vegan. They call it vegan omega-3. Algae can be used as fertilizers, can be used as animal feed, can be used as human consumption, so that it's not only energy, it's also providing the environment with a constant, sustainable system. Okay, that is, can cover many areas. Yeah, from water remediation into energy through the food supplements. And as you see here in my slide, I'm saying that we can have energy and we can have different other products. Where did I put this one? Okay. So what did we do? Cultivation of microalgae needs a special way. So there is different way of making the plants. There is a open pond plant, which is you can have something like this. Okay, let's say aqua. ونزرع فيها الطحالب. أنا شوية أتكلم بالعربي. Okay, sorry for that. هذا يتعرض لمشكلة كبيرة اللي هي المشكلة بتاعت contamination. Okay, the open pond, they are subjected into the contamination. So other animals, والنباتات ثانية, الغبار, okay, dirties can be also accumulated as a contaminant. So these types of plants, we cannot use it for the food supplement, but it can be used to generate electricity, but in a short range, because with time introducing into the market. One of them is called LED, internal LED photobioreactors, or tubular photobioreactors. And at Geotech, successfully, my teams designed and automated a photobioreactor, tubular photobioreactor. This is done last semester, and the team won yesterday. Yeah, they won a prize for the upgrade for their project. So now they are becoming a startup company. One of them is here, Miss Muna. Okay, so we built our phototubular. We started, we automated. Also, we have some microalgae from our partners, استزرعناهم في اللاب. And then we will continue the project in collaboration with the Oman Hydrogen Center at Geotech to have our hydrogen production. So what will be the steps? أول حاجة, a design is complete, automated, نواصل فيه إن شاء الله. عمان غنية جدا بالبحار. ممكن يكون في حوالي 300. Okay, many researchers are working on identify these types of algae. Yeah, classify them and specify them because it will be also a market. It's not only the hydrogen, also the algae itself can be a market. Okay, we will do the second step, that to identify which species will be the best in hydrogen production or energy biomass production. Okay, by doing some physical and chemical tests. Then, after that, we will cultivate it using our tubular, and then we will go further in the second step. To have the best energy production, we need to set on not only the conditions, the pH, the temperature, the salts, the nutrients, وكيف السبيشيز نفسها. No. The method, how we produce. Okay? There is different methods, as I said. The first one is water splitting photolysis, which is they use the sunlight or the photo. Second one is the dark fermentation, تخمر, ظلام. Okay? Third one is photolysis. Okay? Not splitting the water, but is photolysis for the material itself. And the last one, which we will work on it, or we start to work on it, is the microbial, using the fuel cell, microbial electrolysis process. So this is through, now we come to science. I will not talk in details, okay? This is through what we call it Coulson-Fulmer equations, yeah? And it depends on the current density, how much it's produced, this is the coefficient, the Faraday, and the equilibrium potential, and the differences between the equilibrium potential and the equilibrium between the electrolyte and the electrode. This is how the microbial fuel cell will work. Yeah, and we are working to maximize and find out the better variables from this equation. The second one is to maximize the concentration, substrate concentration with producing energy through Mond's equation, and the types of the substrate. So we need to work on the models, or we started already using simulations. We are working on the models to find out the best substrate, the maximum concentration of the substrate. And as you see here, the simulation will be in 2D, microbial fuel cell, solving mass charge balance, Mond, Poulter, Fulmer kinetics, and we will use the microbial fuel cell will be simulated and modeled and see the maximum hydrogen production. Yeah, I think I came to the end of my presentation. Yeah, and I would like to thank the team that is helping me here, and also the reference, and later, of course, we are open at UTech and the Oman Hydrogen Center. We are open for collaboration, for investment, for any feedback and questions. Thank you very much.
سعادة رئيس الجامعة المحترم، أصحاب السعادة، أيها الحضور الكريم، ندعوكم الآن لأخذ استراحة قصيرة.
Test. Test. Mic one, two.
Another one.
Okay.
Merong pasok. Sana.
Bakit? Hello, test. Test mic. 1, 2, 3. Test. Test mic. Wala. Wala. Test mic. 1, 2, 3. Okay. Maybe Maktoum. Maybe Maktoum. We will ask Maktoum.
Maktoum or Saud also?
Yes, we will. One in here. Left and right. Test mic. 1, 2, 3. Test. Test mic. Ayan o. Oh. Ayan o. Oh, hello. Test. Ayun. Meron na. Meron na.
Huh? It's okay?
Test mic. 1, 2, 3. Wait. Wait, I will check that. Test mic. 1. Yeah, please.
Test. Test.
Test mic. Test mic 1. Plus, plus na maximum.
شغال عشان الفريم
عشان تشيك عليه.
هذا اثبته وين؟
قريب شوي.
اجربه؟ يا
لا اوبن انت خلاص. لا تتكلمي بس.
اوكي يس يس نو ساوند
بس انا
اروح It's far, huh? Where it's supposed to be? Hi. But I think it's deviated a little bit and my... Yeah. Hello. Yeah. It's working, huh? Even if I do like this, it will come. Yeah. Hello, how are you? Okay, no? Yeah. Louder? No, my voice is loud. It will come gradually. Now I'm just heating. Make it a little.
ستمضي بكم سيدي منار السلام لمن يقتدي، ومسرى الأمان له قبلة ضياء منير على المشهد، وأنت المعظم سلطانها، وهذه عمان بكم تهتدي. ومن نهضة في مسار العلا إلى رفعة في ذرى الغرقد، سنعلو وقائدنا هيثم كريم الأماجد والمحتدي، همام تمثل فيه الوفاء وريث السلاطين من أحمد. عمان التقت على عزة سرورا بمقدمك الأمجد، أتتك الزعامة مختالة وأنت لعليائها مهتدي، فسر في طريق المعالي بنا فإنا على الوعد والموعد. وهمتنا جاوزت في المدى مدار السماء على المرصد، وعزوتنا شأنك المنتمي إلى العز والجاه والسؤدد، لك المجد سلطاننا هيثم، لك الوجد من حبنا السرمدي، لك الوجد من حبنا السرمدي، لك الوجد من حبنا السرمدي.
قبلهم بينس.
فلوس. اثنين اثنين 1 3 8 4.
Test mic, test mic.
Walang sound.
Test mic 1 2 3 test mic 1 2 3. Test mic 1 2 3.
بين المؤسسات مختلفة، تعاون بين المؤسسات والصناعة والاستعدادات للعمل. هذه اللي هم المحاور العامة. لكن الأستاذ علي قال يعني هذول الناس اللي موجودين في الصحفين هذول عربي أحسن عربي عشان بعد السرعة. بدأت بالإنجليزي بعدين كلمت عربي. تقاهي توصيات التقاهي كان يتعلق بس التوصيات المأمول. أيوة.
Test. Test mic.
Yung lapel.
test. Mic 1, 2, 3. Test. Mic 1, 2, 3. Yan. Masyado nagkahang. Masyadong mataas. Mataas siguro ang sensitivity.
Teka.
Baba.
Cocktail naman.
Oh, sige lang. Then, pinaba ko yung sensitivity. Test. Mic 1, 2, 3. Test. Mic 1, 2, 3. Test. Mic. Ha? Test. Mic 1, 2, 3.
there is a kind of echo there. خلاص. ايوه اذا بروح ايوه توكلنا.
سعادة رئيس الجامعة، راعي الندوة، أصحاب السعادة، أيها الحفل الكريم. يحل الهيدروجين الأخضر مشكلة كبيرة كانت تواجه الطاقة المتجددة، إذ يعتبر إنتاجه بواسطة طاقتي الرياح والشمس نوعاً من التخزين، حيث تحول الطاقة الناتجة عن استغلال أشعة الشمس أو تيارات الريح إلى طاقة هيدروجينية يمكن استغلالها في تشغيل محركات السيارات أو أي استعمالات ميكانيكية أخرى. ندعو الآن الدكتورة منى بن درويش المعمرية لإدارة ندوة الهيدروجين الأخضر بمعية المتحدثين.
بسم الله الرحمن الرحيم. طبعا هذا الجزء هو أكثر جزء يعني انترستنج وشيق الجلسة، لأنه بيمثل إن شاء الله يعني جلسة نقاشية حوارية من خلالها إن شاء الله رح نوصل إلى توصيات الجلسة. في البداية نرحب بالتيم البرزنترز، دكتور سوسن الريامي and مس نجد الرئيسي، دكتور يثرب and دكتور راجا موهان. Thank you very much for your participation today and your attendance and that interesting presentation that you offered for us today. So I think it's the time to start, and we will start with the first presenter, Dr. Sawsan Al-Riyami, the director of Oman Hydrogen Center. Our discussion will be inshallah in English, and we may يعني go to Arabic sometimes. We want to use only Arabic, but since Prof. Raja Mohan, so we'll shift it. Yeah, no problem. So we'll start now with Dr. Sawsan Al-Riyami. Dr. Sawsan, based on your presentation, you spoke about your cooperation with Geotech and SQU in the field of the research, and especially in the field of the green hydrogen. Do you have any other plan? Do you have a plan for working in the field of the green hydrogen with other institution, higher education institution?
My job is hydrogen, so of course we have a plan, and it's a short answer. And usually in the Oman Hydrogen Center we have a practice that we learn it by heart from industry, that they called it engagement plan. An engagement plan that you map your stakeholders and our stakeholders, and you mentioned it's written by industry. The needs of industry listed out what is the direction of the research itself. Once the direction of the research has been set out, then we are hunting the expert. The sky is our limit because we are located in German University. This center is owned by the German University of Technology, but the direction from the whole management and everybody is we are wider than Germany. We are willing to be the gate of Europe when it comes to technology transfer and technology hub. And one of the proof of that we just accomplished one project with Delft University with Professor Rock and his students, the master students, and their case was from Rotterdam Port. And
So you start from German university because your location, the location of the center is from there.
Yeah. But
And then now you
yes.
spread your.
Yeah, we are open heart, and
Yeah.
we are about to cooperate with Japan, so we are open to Asia, and Korea is approaching us.
Good. So you already start some projects with them, or you are planning to start?
The one with Netherlands is completed. Last week we was in Sahar where we just complete and present the project, so it's over. And the other project will be with Germany. We are planning it already. And the one you mentioned with Sultan Qaboos University, it was the first project.
Yeah, it was
the longest project.
Yeah. And that one was long time ago, or currently you are working on that one?
Since I joined recently, so it's not that long time ago. It was the Oman Hydrogen Center first project because I personally believe that we should not look so far with our colleagues just surrounding.
We have to start from our area first, and then we can expand.
Technology labs,
Yes.
with Dr. Mohammed Al-Abi.
Yeah, Dr.
And
Mohammed.
we are looking for produced water. Produced water, for non-expert in this area, it's the water coming with the oil inside.
Yeah. So how you use the green hydrogen? What is the relation between the green hydrogen and the water research and the SQU?
Yeah, so see, the value chain of hydrogen, you need a source. With any energy that you are looking for with the source.
Yeah.
If you want electricity, you might go with the sun and the wind in Oman, so you are with photovoltaic or solar thermal or with the wind itself.
Yeah.
Then you will have electron. The question is from where you get the hydrogen.
Yeah.
Either you go and crack the gas and then you are with the green hydrogen, or you use the water. The other question is from where you get the water. Either you go with desalination water.
Yeah, so you start from the seawater, you make the separation.
Yeah, and or you go with the wastewater, then as Dr. Yafir may elaborate on that.
Yeah.
Or you go with the produced water, which is a critical problem for our industry. So that's why we selected the produced water.
Yeah.
And it is a quite challenging project.
Yes. So now the second question is, you have collaboration, you are planning for a collaboration, and you already start that collaboration with external, universities. Yeah. But what about our universities in Oman, that higher education institution? Okay, with the geotech it's already done, with SQU, yeah. But what about the others?
With local.
Yeah, only examples about the plan. Maybe we are planning now. Maybe from this event you will start.
Yeah. So I'm now visible, and our Oman Hydrogen Center, our contact is already there. I have already a colleague that we wish a cooperation between our colleagues, but not really in hydrogen, towards sustainable environment. When we say sustainable, that means you also want to work decarbonization. It's not necessary to be hydrogen.
Yeah, not hydrogen, in general.
But answering your question in short, we are quite flexible, fast,
very good.
Open.
So you want to collaborate with UTAS branches if we are forming, if we are planning to form a team for the green hydrogen.
Yeah.
So So you have a willing to collaborate with us, because you are representing your center. Yeah.
Yeah, please involve us, and we will try to support.
Thank you very much.
We are the right client.
Thank you very much. Thank you. And now it's the time for Ms. Najd Al-Raisi from Okio. Hello, how are you?
Well, thank you.
Ms. Najd, I think you are working in one of the large projects there in Okio related to the green hydrogen. Can you please give us just something like 1 minute speaking about your project there, far away from that slides? We want just simple information about your project. What do you expect as a final result from your project? Any important details? 1 or 2 minutes only.
Right. It's going to be hard, but I'll try.
Try to simplify it for us in order to understand it.
So one of the projects I worked with is called Green Energy Oman, or GEO project. It's one of the projects in Moscow, specifically close to the comfort area. And what's exciting about this project is the end result is that we want to be producing about 25 let's say class of 25. Now anybody, obviously the students who are working and studying in this area, 25 is a lot of a scary number. So the exciting part about the project is that it's going to be with a lot of phases. And so we're not going to be doing the 25 kilowatts all at once.
So now you are in which stage in your project, I mean?
We're still assessing, we're still
Yeah.
in the feasibility stages. So obviously with green hydrogen, since it's a new endeavor, not just for OQ but for the country as a whole, it's going to take a long time for things to come online. That's why when I presented, I portrayed the low carbon molecules project as being part of OQ's long-term plans.
Yeah, so you just start the project.
Exactly.
Yeah, and you are planning for many things in that project. But your final result for the project, what do you expect at the end when you will finish it as a final product from this huge project? What do you expect at the end?
We expect to be converting the green hydrogen into ammonia.
Into
So
ammonia.
I can't give you an exact number because we will not have But the end result is going to be green ammonia for export.
But now what I understand from that presentation also that you are doing some projects and you are planning to use that hydrogen for the industry. And is there any chance to use a simple percentage of that hydrogen for the research purposes? Because in the academia we are interested with using hydrogen for the research. Is there a possibility to use hydrogen from the projects, any of your projects, for the research purposes in the academia, in any of the institutions?
Obviously, OQ will support research, especially for students. OQ as a company, I don't want to speak on behalf of the whole company.
Yeah.
But obviously, I haven't met a person from OQ who's not in support of the youth and the upcoming generations. For the projects I spoke about specifically, they already have a clear vision of where we want our end product to be, which is for export. But that doesn't mean that in the future we cannot plan to develop a pilot project, for example, where some of the product can be used for research.
Yeah. So if the student, they are planning, for example, if one of the, from any of the higher institution, yeah, they want to visit, OQ and that electrolysis unit there. Are they allowed to go to this system and see the details of the process there? Or they are restricted, they cannot do?
I feel like this question puts me in a tough spot because I'm afraid I have to tell you that we don't
Yeah.
have an electrolyzer facility.
Yeah, you didn't have that.
No, we don't.
So what I understand that there is a diagram of what, steps there. You start from something and you produce hydrogen.
That's the
You are using membranes.
That's the project.
I imagine that there is a unit there. And so they can go and see the units and follow that hydrogen there where they store it. Yeah.
This makes me sad because I wish I was in a position where I could tell you that, definitely you're welcome to come visit our electrolyzer facility, but no, not yet. But
it is not yet open?
Not yet developed.
Yeah, you are designing that unit?
We're still waiting for land from Hydro.
Yeah. So still, it's very early stages. You are in the very early stages. Yeah, you will invite our students there?
Yes.
Okay, very good. So thank you in advance. We hope, inshallah, one day that when you will start that unit.
Inshallah, but I encourage any of the students that if they have any questions regarding green hydrogen or decarbonization or more broadly alternative energy to always reach out to either myself or the team.
Yeah. So maybe you will organize something like lectures or something for the student and invite them. Even theoretically, they can come and attend because you are, in contact with the project. So you can just, educate them regarding the green hydrogen, a kind of education among the students and also the staff if they come to the students.
I would encourage them. So, for example, last week or 2 weeks ago, we had the Green Hydrogen Summit. That was an incredible opportunity because it was open for everyone, all of the MPs to come. We had a booth.
And we happily sat there and
talk to anyone about anything they want to do related to hydrogen.
Yeah.
Other than that, we're also planning on developing communication strategies where we will do outreach programs to educate the public more about green hydrogen specifically, but also decarbonization in general.
Yeah, this is great. Also, this the idea of decarbonization and the idea of the green hydrogen, that clean energy. This is a good idea. But what I want to ask you also, is there any plan also, or maybe you will discuss for the future collaboration I think your hydrogen, the hydrogen that you use in your industry, the source is, what is the source of your hydrogen? I mean, hydrogen that you use in your industry. Your
So like green hydrogen, so it comes from gas.
yeah, it comes from natural gas. Yeah. So from the port area only, you find it.
We produce it.
You produce it. Yeah, you produce it, but not with that method.
No,
Not with that.
not
Another.
with
What is the other method used to produce it?
So electrolysis.
Yeah.
Yeah, which is splitting the water out.
Yeah, which is different from that one.
So actually, as part of your presentation, you also presented about the colors of hydrogen. So there is a
There is gray hydrogen.
Yeah, between gray hydrogen to green hydrogen, there is blue. So
and there is the blue also here.
exactly, that's the most promising one in the reason in the near term because you can still continue using gas, but you can implement CCUS, which is carbon capture, utilization, and storage technology. Meaning you can use the gas, you can produce the hydrogen using the gas, but you also implement this technology to capture any emissions, any CO2 emissions. Yeah, so it's not 100% clean.
Yeah.
It's not also like as harmful as the
Something like intermediate.
Exactly.
Yeah. You are trying to exclude the CO2 during that. Okay, it's okay. Seems to be clear now.
Thank you so much.
Thank you very much. Thanks. Dr. Yathrib. Thank you very much for that unusual presentation. It was very interesting because, you know, you ask a question for the student and for your team, I mean. Yeah. Yeah, plus you interact with the audience, so it was very nice presentation. As a teacher, I evaluate that presentation. And of course, the other presentation was very great also. So let us go back to our green hydrogen. Okay. Can you please give us some, in 2 minutes, what are your current researches in the geotic related to the green hydrogen? Okay. Victoria Hind, yeah.
We expected that Dr. Hind Harabash, the HUD of the Engineering Department, was also working on the hydrogen from sludge. And I think the student won a prize in the hydrogen summit last week.
She published a paper about that research.
Exactly.
Okay.
And the students also. And they presented a poster during the hydrogen summit last week, and they won the first place.
Very good.
So the
Congrats.
idea is to generate hydrogen from the sludge.
Yeah.
So using fermentation.
So there is a team there. You have a team in there.
We have a team.
In geotech?
Yeah, and with the lead is Professor Soustan
Yeah.
from Hydrogen Center. Good that he
So
is
I want to speak about that collaboration between that center, the Hydrogen Center, and geotech.
Yes.
What is the intersection area, I mean?
We are very happy that she is there and inside the geotech.
So what is the aspects?
We can approach her anytime.
Yeah, yeah.
First of all, in research, because she is an engineer and scientist.
Yeah.
And also, she's a director, and she has also the hands on the strategy, design, regulations. Also, she has also collaboration with other investors, companies like OQ, Vitrofan, and so on. So we have that.
So that means you are lucky because that Oman Hydrogen Center is a part of that of a geotech university, German university. That's why you are very, very lucky. Yeah, and you know, that means there is strong collaboration between you and that center. Yeah. So is there any, common research?
Yes, we do.
Yeah, and current research now with the name of this center plus geotech. Yeah.
We do have current research actually. Dr. Sultan and I supervise the students during their thesis and also prepare the students for their master journey or career journey. And we supervise students in the field of hydrogen production technology, or science. Yeah, and for example, Dr. Sultan and I are working on developing the battery and the fuel cell. The battery for the storage and also the fuel cell. And now also we will work together in the microbone fuel cell, MXT.
Yeah.
Also, Dr. Sultan also working with Dr. Hind in the same program as such.
Yeah.
Yes.
So you have that main research under the supervision of Dr. Hind. Yeah. You are part of that team.
I'm a part of the team.
Yeah.
It's a higher.
Yeah.
Yes. And also, alhamdulillah, also we have some professors and researchers storaging from the geoscience department.
They're in geotech itself.
Geotech itself,
Yeah.
but they are also would like to start working on the storage under the ground, which is using the geoscience technology.
Do you have any collaboration between geotech and any other government university in Oman, like SQU or any other?
We do have, for example, the photobioreactor. It is, we had some help from the TRC.
TRC,
yes. And we are collaborating with the oil and gas center.
Yes.
Dr. Farouk.
Yes.
We are always sitting together and discuss some because to be honest, I started my research in oil and gas to find also a green solution.
Yeah.
And then also now we have the hydrogen because I came back to my master.
Yeah, that's why. Yeah.
And UTAS,
So you have collaboration between them? In which aspect, I mean?
Not yet.
Not yet. You are planning to? You are planning to do?
Yes, inshallah.
This is good.
Asif, also now we're starting.
Yeah.
Yeah, because he's very brilliant in algae and he has a lot of research in algae in other areas, but to make the research stronger, collaboration needed. Because each one of us has background and knowledge that we can utilize to make it to have a high quality.
Yeah.
And we need engineer, we need a scientist.
Yeah.
Yeah, we need logistic or economic or business. Yeah, to do the visibility to help us in the visibility studies and technical things. Yes. All these so to make the research stronger.
Do you have any other collaboration with the private universities? Specifically, and you already start or you have a plan to start?
We are planning to start inshallah
with
Nazrul
University?
Yes, we will have a visit inshallah next week on Monday.
Inshallah.
Also, we are having collaboration with, as I said, UTAS Muscat.
UTAS Muscat.
Yeah, I hope we will open Shiraz a little far, but we have teams.
Okay, no problem. It's okay. Once you start from Muscat, that culture will spread, Welcome. Yeah. Thank you very much, Dr. Yathrib, for your information. And now it is the time for, Prof. Prof. Raja Mohan. Thank you for your participation today. And I just want to ask you about the research in general in the field of energy on the level of Suhar University. Can you give us something like 3 minutes speaking about your current research as engineering department, I mean general, or if you have specifically some of the research related to the energy and the green hydrogen?
What is he give 3 minutes like?
I can give you one more, no problem. 3 minutes because that long question is there. Yeah, so many parts are there. Yeah, she can continue.
That means Dr. has high expectations for me, it's part of God.
That's why.
I need to compliment what has been said already.
Yeah.
So we have been working on the key areas of engineering research, namely energy and environment. That's how we see us.
Yeah.
We do have our own plans on energy research.
Yeah.
Where we work on solar PV since long time. And we have been working on bioenergy, especially from whatever the doctor has said. We have been doing the same in a different line.
Yeah.
We have been working on algal biomass to energy, but not necessarily hydrogen. We do work on methane.
Yeah.
We work on biogas.
Yeah.
The new direction on biohydrogen. And we have started working on promoting industrial wastewater to biohydrogen.
Yeah.
Due to some non-disclosure issues, I can't explain all what
Yeah.
we are doing.
No, just briefly.
Yeah, that's one priority. And currently we are focusing on developing new membranes. New membrane material for fuel cell applications. Working on new membrane material.
Yeah.
So the material what we are going to produce will have very high selectivity, cost effective.
You conduct actual research there with published paper related to that?
It is under development.
Or is it on the level of the student project only now?
No, it is a PI-led project where master students work on.
Yeah, good.
Project led by academic researchers.
Yeah.
Where our master students work on these topics.
This is a good idea. Instrumentation and is there in your university?
We have created a facility for preparation of membranes.
Yeah.
And we are preparing membranes now.
Yeah.
And we are in the process of feasibility testing the properties of membranes. Subsequently, for fuel cell, microbial fuel cell applications can be extended.
Yeah.
But we work on the upstream side preparing new materials.
So now you are just on the level of the master projects, yani, for the students. Student project.
Student part of the team. But
Yeah.
It's a project which we aim to work with
Yeah.
industrial partners.
Yeah.
It's not for any academic research. And subsequently, we work on some interesting prospects on how do we get hydrogen from industrial effluents, effluents, using some new reactor dimensions.
Yeah.
We are working on novel reactor designs.
Yeah.
This is our
reactor design. Yeah. So now you are collaborating also with another government university or private university. Is there any?
It should be very straightforward. It is academician to academician collaboration.
Yeah, in the field of the research.
But it is not a strategic collaboration with an institution.
Yeah.
We are working towards that.
Yeah.
We are currently.
You want it as a plan?
Yes.
Yeah.
Currently with Sundar Gamas University and the College of Applied Sciences, Utah Soha.
Yeah.
We are working on certain plans where we plan to work on a certain specific topic.
Yeah.
And where we want to work down.
Do you have willing to work with the Utah's team if they form a team in the green,
Most
hydrogen? Thank you.
I would like to take this opportunity and some employees of Utah Soha have planned to enroll their PhD program with Soha University.
Yeah.
So it's capacity building for Soha University.
Yeah.
For Utah Soha.
Yeah.
And it is sharing of expertise for Soha University.
Yeah, thank you very much for this willing to collaborate with us. And now we will give the chance for the audience to ask you questions in the field of the green hydrogen. I think it's the time now, if they won't have any question. So Mike. Yeah, I think you are need for Mike. Okay, Dr. Kondaya, please. Yeah. Yeah. Please, Dr. Kondaya.
But I have some doubt on microbial process for the production of the hydrogen gas. So what is the process of the microbial for the production of the hydrogen gas? Here, small doubt for me. During the process of the development of hydrogen from the microbial process, so here any catalytic we have to add for the initiation for the generation of the hydrogen gas, any catalyst?
That means you are asking Dr.
Yes.
You are chemist and she is chemist also. That's why. I expect repulsion, but I find attraction. Unexpected. Okay.
The first question for me?
The first
yes.
question come for you,
Okay. Yes, for the microbial fuel cell, yes, we need a catalyst to speed up the reaction because I expected to have a question from you about the feasibility study. Is it having any feasible that we can produce hydrogen from the microorganism in a larger scale, or how much we need to invest and so on. So to make it clear, the dark fermentation and photolysis, it's time and produce a small amount. So to speed up, we need to add a catalyst. The most important things in this technology is first to start with the genetic engineering to modify the species itself, and then we have a substrate. And for the substrate we have a catalyst to speed up the reaction. If we have the microbial fuel cell, of course, to speed the electrolysis, we need to add some catalyst.
Second doubt, but how long it will support the production of the hydrogen gas by using of the algae? How long it will support?
Which process? Because we have direct, indirect, dark fermentation, electrolysis. So it depends on the species.
Yes.
It depends on the method that we use it to produce the hydrogen from that species. Is it indirect or direct? Okay, and it depends also on the the culture or the other factors like the temperature, the amount of the oxygen. So some of the species or some of the microorganisms cannot tolerate oxygen. في كتير أخرج died. Okay, so it depends on that. To be honest with you, يعني, I read some visibility studies. They found that the coralla, for example, they need times to produce a hydrogen. It can reach around 1 liter for 1 liter. Okay, but it takes time. Yes. So by speeding, because of this, we are going to use the microbial fuel cell to speed up.
Sir Rajan, sir.
Another question for Prof. Raja.
Compliment what you're saying.
Yeah.
All the biological process of that is slow.
Yes, sir. Yes.
And any day you can't expect a result tomorrow, of course. We need time to initiation, stabilization, I should say. There are a lot of other hidden activities which we can't write in the mechanism.
Yes, yes.
Biological process.
So we have same question for Prof.
No, other question, madam.
Other question?
Yes, yes.
So you just continue.
Sir, I have one question, sir.
Yeah.
Already have given some of the methods for the storage of the hydrogen gas. In that one metal you have mentioned that metal, I think, organic frame works, metal organic frame. How it will support for the SS? How it will support for the storage of the hydrogen gas?
So as I said, metallic organic
Frames, yes.
They do have a tendency to develop a bonding which is weaker. It
Yes.
can be reversed.
Yes.
That's why they categorize it as chemical process. It's not a physical process.
No, here doubt for me, it is a complex structure.
Yes, exactly.
How it will release easily to the hydrogen gas immediately?
It is purely controlled by the pressure and temperature conditions. It's not going to be, as you say, it's not easily reversible.
Yes.
At the high pressure condition, it could be reversed. It's purely
Yes.
controlled by the high pressure and temperature conditions by which hydrogen dehydrogenation from MOF cap is proved is being done.
Yes, yes, yes. Thank you, sir.
Any other question?
Yeah.
From there, students, I think they want to ask.
May I?
Yeah.
Excuse me.
Please.
Here.
You
Yeah.
start?
Yeah,
Okay,
please.
no problem.
Thank you for this chance and also for the informative session that you have provided. Abdurrahim Al-Umairi from UTAS Muscat.
Yeah.
I have actually, I was about to ask Dr. Yathrib one question about how the photoreactor can be competing with the other process of producing the hydrogen. But it seems you relieve the pressure from Najd by saying still you are working to make it more feasible and you need to work on that. Is that right? And so my question for Ms. Najd, what is the roadmap of producing the green hydrogen? Because it seems we cannot move directly to the green hydrogen. So there is a gray, blue, and eventually like green hydrogen. What is the roadmap as per your study? When we'll be able to make the green hydrogen more feasible and competing with the other method of production? Thank you very much.
So I think you will start and she will continue.
Yes. So why? Because we can utilize everything. I said that our way of using microbial or microorganism will compete with the proton exchange membrane and so on. Because we have a lot of factors including wastewater, treatment, water irrigation, carbon dioxide capturing, reducing the carbon intensity or the carbon dioxide intensity. And the byproducts can be utilized in other things, yes, like, as I said before, fertilizers, animal feed, and so on. At the same time, we have energy, okay? Yes, the microbial fuel cell is still under development, not only here in Oman, but also outside. So they are working to find out the best electrodes, the best electrolytes, okay, and the best membrane to transfer the electrons. But it's the same as other fuel cells also under research because they want to develop it under development. So we can say the same, yeah. The good thing is that in Oman and Dr. Asif, he corrected me that there is no only 300 microalgae present in Oman, maybe 6,000. I didn't know that. Thank you. Yes. So this is waste of
want only
Thank
the
you.
transition. So the other part now.
I guess I would say to Dr. Yathrib that we welcome all types of hydrogen. The more hydrogen, the merrier. But to answer your question, starting with gray hydrogen, so gray hydrogen is the conventional method. It's what's widely used today, just using non-renewable sources of energy to produce the hydrogen. Then to transition to green, we have blue hydrogen. So blue hydrogen is still producing hydrogen from either, like I said, non-renewable, so it could be coal, could be gas, but you implement measures to capture any emissions that are emitted along the way. And so to capture emissions, there are two ways, two methods at this point. So you can either do direct air capture, and you just think, you have your production facility, you build another production facility to capture the air, process it, filter out the carbon dioxide, and then you can store that carbon dioxide. Another method of capturing the emissions is what's called stationary capture. So alongside your process, you implement this technology to capture the carbon as it's being emitted from the process itself. And so doing that, you can produce blue hydrogen. And like I said, in the near future, that's where the most potential for hydrogen production is. You cannot go directly to green. There has to be a transition period. And then other than green, green is straightforward. For us, at least in Oman, it's to use solar and wind energy, and then feed that into an electrolyzer and produce your hydrogen. But there's also other types of producing hydrogen. So there's pink hydrogen, there's turquoise hydrogen. There are different energy, there are other energy sources, but like I said, more hydrogen, the merrier.
I might add one thing here.
Yeah.
When strategy is being asked, it's not about OQ alone, it's also about what Oman has been set as a target. If we recall Thomas Costa presentation, since he's not here, I will just bring it to your mind that Oman already announced her strategy, 1 million ton a year by 2030. It's massive. And if we would like to make it in a green, in my opinion, since I'm one also in the panelist here, it's also about the off-taker. If we did not secure right investor, serious investor, with true off-taker, with a clear standardization for the element that we are shipping, we are not really in the right track, because we are not aiming to use all this hydrogen for our own. We are also hunting and exporting element, which it is to diversify our economy. So this is not about our companies or industry vision. It's coming from top down, and I think we should be a little bit aligned with what have been announced recently.
So more questions?
Thank you very much for this elaboration. And just I have, if may,
because
I
you
just
already asked,
very short question, because it is
not
not highlighted in the presentation.
Yeah.
Actually, there are some of the scientific papers which showed also there is some harmful byproduct which come from the hydrogen.
Yeah.
All right. So I'm not sure what is the level of academia over here, how they are trying to track actually this concept. All right, because it is reported that some of the hydroxyl might be generated after the combustion of the hydrogen. So how we are avoiding producing like more harmful
You can
product.
give the answer in 1 minute for this question.
Thank you.
Just 1 minute, because we have many other questions.
Of course, there is no one clear answer for this. It's still under development, and there are byproducts, as I said, along with hydrogen, we could do hydroxyl ions, but the more specificity of the membranes can reduce the release of hydroxyl ions. We cannot stop them from producing, we can filter it clearly from hydrogen. That's how
membranes and filters.
So the idea also to convert the hydroxide into, again, hydrogen and oxygen breakdown. So there are another technology they are working on.
The opposite.
Yes, my question, first of all, my name is Adam, I'm a senior engineer from Oakwood State. My question to Dr. Sousan, you have showed a really great roadmap for the H2, starting from rules and regulations, policies, developers, even financially shipping. However, I could not see the pricing strategy for the H2. Moreover, as you say, did we just find our buyers for the H2 which will be producers? Or alternatively speaking, if we did not find yet the buyers or the buyer's future is not that much secure, how alternatively we are able to build domestic consumers or sectors for this H2, which we will produce?
It's an excellent question. Yeah, thank you very much for the question, and I will start from the last one. How do we create the local demand, if I understood it correctly? I think, again, you did not see a dollar sign on my presentation because it's expected to be from the industrial previous presentation, and sometimes we are restricted to show those dollar signs. We already presented last week on Soharbort. This is one. Number two, if we wanted to create our local demand, if I think about it quickly now, don't judge me in this, we can review it together. I think the heat demand is critical here as a local demand. And not all things could be covered by photovoltaic or solar thermal, because solar thermal with certain limitation, first you need the land, and then you will think about another aspect, which is energy security. So if you are thinking about the energy security, is how to store it. So I will vote more towards solar thermal and hydrogen. Then if you think about the massive energy you needed to replace anything coming from the gas, to feed your local demand, which is based on heat, then I think heat will be overmapped, and then you could replace it. I think High Flight team already decided a few work group people, which Oman Hydrogen Center involved with the policy and regulation, but there is other group which renewable energy, and the other is infrastructure. And they are taking in their perspective this very, very critical things. It's not just to export, it's also our gas will be finished sooner or later. How do we utilize the local demand? And about your first part, the question, if I understood it correct, was did we secure the investor or serious investor or the demands or? Yeah, it's the off-taker. Actually, partially the off-taker are the investors somehow, because I think the German was here. They would like to sign with us, with a key player, I think, together with OQ themselves, when it is Siemens, Linde, and the Japanese are there, Marubeni, and Dimi, one of the biggest announced project here in Oman, it's Belgium. And I think in the level of the kingdom, it's been a signing ceremony. As also the first presentation covered, there's a visit to Germany. His Majesty visited Germany last few months. But if you asked me who is the off-taker for Oman, for us as a local player, if you see this hydrom orchestrating things, the off-takers come to hydrom because they wanted to secure the land. So I think it's bigger than one company handle. So example, if you take Japan, because it's easier to me to just to throw an example about Japan. Japan eventually, they don't want hydrogen, they want the green ammonia or ammonia. Now it's okay for them, blue ammonia, because the whole system for electricity is depending on ammonia, so they don't really wanted the hydrogen. So if they will become our off-taker here in Oman, they of course will partner with Kosira, and the Kosira is the one who responsible about their electricity sector there. The developer here in Oman, it might be any other company like Mitsubishi, Marubeni, Mitsi, Sumitomo, or other, and themselves might not be enough. They have to find another alliance, and according to the new way of doing this business, they are encouraged them to go with local partners, which it is OQ somehow. kind of developer. And then Asyad will come at the end. So I think it's the alliance, and the off-taker is the one who in the level to select his partners, if I answer your question.
Sausan, thank you very much for this information. And now we'll give the chance for one of the audience there, please.
Assalamu alaikum. This is Yusuf Al-Mabsali from Ibra branch. Thank you very much for this lovely presentation. I have just one question regarding the return on investment. I've seen that, like, there's a huge investment is running on all of these projects in green hydrogen. I also quoted from the newspaper, this Oman targeted to invest around $140 billion in green hydrogen by 2030. Now, my question is, how much would that contribute to Oman GDP economy by 2030 and 2040 and 2050, for example? Because I've seen that in one of the presentations, I think by Mr. Thomas, that by 2050 there will be great investment, approximately around $1,400 billion in Oman for. So, because that is absolutely reflecting in Oman economy. But how much that be contribute to Oman GDP in general? Thank you very much.
Maybe we will go again to Dr. Sausan, because that Mr. Costa is not there, or we may ask Mr. Najm.
No, I think like,
Yeah,
I don't want to speak out.
she's the right one. But you have something like 1 minute, because the time, 1 minute only.
Yeah, so it's the 30 second. I think what Tom Costa already described, it's under, that was a result from visibility. So by diversification, by adding hydrogen toward diversification of economy, there is perspective and element to it. Like you are saving the gas, you are adding this. But we can, of course, after this panel discussion, sit with you, because I like this question so much, and we could link you immediately to the Tom Costa to answer you in details. Yeah, thank you very much.
Thank you very much, Dr. Sausan. And I think it's just 1 minute. Yeah, thank you. Now you are restricted with time. Okay, so by the end of this panel discussion, thank you very much for all, the presenters of the paper and for all of you.
Thank you.
And thank you very much for, I think, the audience that are patient and you are listening for all of us. Okay, so I think it's the time to close this panel discussion, and maybe we are preparing ourselves to go for the recommendation of this symposium today. So thank you very much again. Thanks a lot. And
thank you to the organizer. Thank you very much.
recommendation.
نشكر الدكتورة منى المعمرية وجميع المتحدثين على ما أفاضوه علينا من معرفة. وقبل الختام ندعو سعادة الدكتور سعيد بن حمد الربيعي راعي الندوة لتكريم المشاركين.
توصيات في النهاية. الله يبارك فيك، يعطيك العافية.
قبل نبدأ التكريم بداية نحن سعداء أن نكون معكم اليوم، وأيضا نقدم كلمة شكر وتقدير لفرع الجامعة في شناس واللجنة المنظمة برئاسة الدكتور أحمد جحري وجميع الأخوان الذين أسهموا في هذه المشاركة، وأيضا كل المدعوين والمشاركين، وأيضا شكر خاص لمقدمي أوراق العمل والمحاضرين الذين أسهموا معنا اليوم. أنا سعيد اليوم أن أرى هذا الزخم وهذا الحضور في هذه الندوة التي تتوافق عن التوجهات العالمية وأيضا عند توجهات الدولة والحكومة هنا عندنا. والحمد لله هناك كثير من المشاريع الواعدة التي ذكرت من خلال هذه العروض المرئية التي رأيناها، وهي موجودة على أرض الواقع، نبني عليها الكثير من الآمال والطموحات خلال الفترة القادمة. الهدف الرئيسي من هذه الندوة أن نجد هذه العلاقة الوطيدة بين القطاعات المختلفة، سواء كانت قطاعات حكومية متعلقة بوزارة الطاقة والمعادن فيما يتعلق بدورها المعهود في موضوع العلاقة وبناء العلاقة والسياسات والخطط والبرامج المتعلقة بالطاقة المتجددة، وخصوصا ما يتعلق بالهيدروجين الأخضر. وأيضا هذه المبادرات الطيبة من الشركات الفاعلة في هذا الجانب، وكذلك الدور الأكاديمي المطلوب الآن. فلا بد من وجود هذه العلاقة الوطيدة بين هذه الأطراف متكاملة. وأيضا احنا محتاجين حقيقة في هذه الفترة إلى بناء القدرات الوطنية الموجودة، وهذا هو المهم. ما سمعناه الآن من استقطاب لبعض الشركات العالمية ولبعض أيضا الجامعات العالمية، ينبغي أن يكون للجامعات العمانية وأيضا لأعضاء هيئة التدريس ولطلابنا الموهوبين المشاركة الفاعلة من الآن فصاعدا في كل هذه المبادرات الطيبة. وأعتقد أن احنا في جامعة التقنية والعلوم التطبيقية لدينا المكنة بحكم وجودنا وانتشارنا أيضا في سلطنة عمان وفي كل المحافظات، وبحكم أيضا وجود يعني كم كبير جدا من أعضاء هيئة التدريس من مختلف الثقافات وأيضا من مختلف الجامعات الذين حقيقة يمكن أن يكون لهم دور فاعل في هذا الجانب. وأخواننا أيضا وأخواتنا العمانيين في الجامعات الأخرى، لا نقلل من شأن الجميع، لكن نعتقد أننا محتاجين أن نكون وأن نتكاتف وأن نتكامل في هذا العمل. عندنا طيف واسع من الأكاديميين من الباحثين، نريد أن نستغل هذه العقول وهذه أيضا القدرات الموجودة عندنا ونبني عليها، وأيضا نستفيد من الخبرات الخارجية الموجودة سواء كنا نستقطبها الآن أو سواء كانت موجودة عندنا. ونأمل أنه خلال الفترة القادمة أن تكون لدينا منصات تعاون ونبني عليها، وتكون لدينا نوع من التكامل، نوع من الكونسورتيوم خلينا نقول، على أساس أنه تكون هذا التكامل موجود والتفاعل موجود والتقارب إن شاء الله يمضي للأفضل بين هذه الأطراف. ويومكم سعيد إن شاء الله، مشكورين مرة أخرى.
توماس كوستا، مدير الطاقة والصناعة بميناء صحار والمنطقة الحرة. الدكتورة سوسن الريامية، مدير مركز الهيدروجين الأخضر في سلطنة عمان. ويثرب عجاج محاضر بقسم الهندسة بالجامعة الألمانية. أما الآن فليتفضل الدكتور أحمد بن سعيد السحري عميد جامعة التقنية والعلوم التطبيقية بشناص لتسليم هدية تذكارية لراعي الحفل. وندعو الآن المتحدثون لأخذ صورة تذكارية مع راعي الندوة. We invite all speakers to take a photo with His Excellency. وقبل الختام ندعو الدكتورة منى المعمرية مديرة الجلسة لتقديم توصيات الندوة.
العفو. شكرا. Excuse me. السهم ده. to use the techniques and equipment in the industry to conduct the research projects related to the green hydrogen in the higher education institution. So thank you very much.
ولأنت يا وطني العظيم منارة في راحتيك حضارة الأجيال. ربنا آتنا من لدنك رحمة وهيئ لنا من أمرنا رشدا. والسلام عليكم ورحمة الله وبركاته.